Okay, friends, let's go ahead and take a look at question number 60. And here we have the word solve for x. Now, we haven't seen this before, not that much, right? Because we actually do have many different representations for this. We'll say solve for x, isolate x. We can also have use x, set it as an equation for x. Now, all of those are the same thing, saying that I'm going to go ahead and solve for the letter x. Now, let's take a look. X show up right here and show up right here. So that means at least there's a step for us to do a combined like terms. So what is going to be the actual correct step? So first thing, I observe a parentheses. Now, to be honest, a lot of people don't like parentheses, so that's the first thing we got to get rid of. Let's take a look. Step 1, break parentheses. So that means I actually need to do a distribution. Distribute the factor. Okay, so in here I have a factor of 2, which is standing right in front, but actually to be more accurate, that's not actually just a 2. It's a whole entire -2. So in here, let me go ahead and break this. I have 7x, stay at the front, I didn't touch it, and have a 3. Now and then, my -2 got to distribute to the 2x and also distribute it to the +1. So -2 times 2x is going to be a -4x. Now again, a -2 times a 1 is going to be a -2. Now I'm going to go ahead and copy the equal sign and equal to 13. Now I'm going to highlight the part that what did I do? I'm going to break the parentheses by distributing this whole thing and make sure that everything got broken down into pieces. Now again, I don't want the parentheses, therefore I break it. What about step 2? Well, step 2, let's take a look. I observe a 7x and a 4x. Well, actually, to be more accurate, it's a -4x. These are called like terms. So I'm going to go ahead and combine like terms. So, and not only just the x's are like terms, the +3 and the -2 are like terms also. So let me go ahead and combine them. 7x and -4x, I have a +3x. +3 minus 2, I have a +1. Well, I'm still going to set it equal to 13 because that's what I didn't change. That's something that you cannot change to be accurate. Now, step 3, what are you going to do? Well, I'm going to go ahead and do a reverse calculation just like the question above, just like question number 59. Number 58, we're going to do a reverse calculation just like here. So, well, I have a +1. So reverse calculation. I have a +1. I don't want it. I have to do a subtract 1 on both sides. So 3x plus 1 equals to 13. I'm going to go ahead and do a subtract 1 on both sides. Now, the reason why we write it a little bit below is because I want to separate it what is from the original equation and what is my action step. My action step is for the reverse calculation. So I'm going to go ahead and make sure that I'm putting it a little bit lower than the original so I can tell that which one is which. Now I know that +1 and -1 cancel out. I left with a 3x. Now I have a 13 minus 1. I left with a 12. Well, again, I'm not done yet. I've noticed that this is a 3 times x. So what can I do? Oh, I'm going to divide by 3 on both sides. Now again, I'm going to do it on both sides to keep the scale balance. So, and again, 3 and a 3 cancels out. I left with an x. And 12 and a 3, I got a 4, since this is a division. Now that's how I have a final answer, x equals 4.